For more than half a century, humanity has been listening to the universe in the same way. We point massive antennas toward the sky. We scan the radio spectrum. And we wait. We wait for a signal powerful enough to rise above cosmic noise, a broadcast, a beacon, something unmistakably artificial. Something that says, we are not alone. But what if this entire strategy is built on a false assumption? What if advanced civilizations don't shout into space at all? What if they communicate in a way that looks less like a radio tower, and more like fireflies blinking in the dark? This idea may sound subtle, even counterintuitive, but it is quietly reshaping how scientists think about the search for extraterrestrial intelligence. And once you understand it, one unsettling thought follows. Alien signals may already be in our data, and we've been filtering them out as noise. For decades, the search for extraterrestrial intelligence was shaped by human history. Radio once defined long-distance communication on Earth. It was powerful, inefficient, and loud. Early television broadcasts, radar systems, and military transmissions leaked enormous amounts of energy into space. For a brief moment in cosmic time, Earth was a bright radio source. From far away, our planet may have looked alive. But that phase didn't last. Modern civilization is becoming quieter. Communication now relies on fiber optics, compression, directional beams, encryption, and low-power transmission. We send more information than ever, while leaking less into space. From the outside, Earth today is far harder to detect than it was in the 20th century. If intelligent civilizations elsewhere follow similar technological paths, then the radio-loud phase may be extremely short. A thin slice of time. Miss it, and the universe appears silent. This creates a problem few people like to talk about: timing. The universe is nearly 14 billion years old. Technological civilizations, by contrast, may remain detectable for only thousands, or even hundreds, of years. Two civilizations must not only exist in the same region of space, but overlap in the same technological moment. Both must still be loud. Both must still be listening. If that assumption is wrong, then silence does not mean emptiness. It means poor timing. Instead of asking what tools aliens might use, some researchers are now asking a more fundamental question: how do communication systems evolve when energy is limited and environments are noisy? Energy is expensive everywhere in the universe. Noise is unavoidable, from stars, magnetic fields, plasma, and cosmic background radiation. Any system that survives long enough must optimize. To explore this idea, scientists turned away from technology and toward biology. Fireflies do not communicate randomly. Each species uses precise flash patterns, specific timing, rhythm, and spacing. These signals evolved under pressure. They must be recognizable to others of their kind. They must avoid attracting predators. And they must conserve energy. Firefly signals do not dominate their environment. They blend into it, yet remain detectable to those who know what to look for. The researchers proposed a radical idea: advanced civilizations may communicate the same way. Not with constant broadcasts, but with optimized, low-energy signals shaped to stand out statistically, not loudly. To test this concept, scientists needed a natural astrophysical background rich in structure and repetition. They chose pulsars. Pulsars are rotating neutron stars that emit highly regular pulses of radiation, some rivaling atomic clocks in precision. They are abundant throughout the galaxy. Their signals are predictable. And they create a structured background ideal for detecting anomalies. In a simulated pulsar environment, artificial signals were introduced. These signals evolved under two competing pressures: minimize energy use and remain distinct from the background. Over many iterations, something surprising happened. The signals did not become complex. They did not encode messages or language. They did not grow stronger. Instead, they became minimal, structured, and optimized, statistically unusual, yet physically efficient. The result was striking. Many of these evolved signals were easier to detect than pulsars themselves. Not because they were powerful, but because they were optimized. They sat at the edge of detectability, too structured to be random, too efficient to be natural. This suggests something profound: detectability does not require power. It requires intentional structure. A signal does not need to be understood to suggest intelligence. It only needs to show evidence of selection rather than chance. Firefly flashes carry no meaning to humans, yet we instantly recognize them as biological. In the same way, alien signals may never be decoded, but their fingerprints could still be unmistakable. From a survival perspective, constant broadcasting is risky. It wastes energy. It reveals location. It creates long-term exposure. Optimized signals, by contrast, are sustainable. They can persist for thousands or millions of years with minimal cost. They are subtle, efficient, and resilient. In that sense, loud communication may be a sign of technological immaturity, a brief flare before optimization sets in. One of the hardest problems in the search for extraterrestrial intelligence has always been distinguishing artificial structure from unknown natural phenomena. The universe produces extraordinary complexity on its own. Stars oscillate. Magnetic fields twist. Plasma behaves chaotically. Many past, alien signals were eventually explained as new astrophysical processes. What makes this framework different is that it does not rely on complexity alone. It relies on optimization. Natural systems tend to be messy, variable, and inefficient. Optimized systems show restraint, consistency, and precision. That boundary, between randomness and efficiency, is where intelligence leaves traces. Modern astronomy has been collecting enormous amounts of data for decades. Pulsar surveys. All-sky scans. Time-domain observations. Much of this data was analyzed using assumptions shaped by human technology. Subtle optimized signals may have been dismissed as artifacts or background irregularities, not because they were invisible, but because we were not prepared to recognize them. This raises a provocative possibility. The first evidence of extraterrestrial intelligence may come not from a new telescope, but from reanalyzing old data with new expectations. And radio may not be the only channel. If communication is shaped by constraints rather than tools, then optimized signals could, in principle, exist in light modulation, neutrino emissions, or even gravitational wave patterns, depending on the environment and energy costs faced by a civilization. The medium matters less than the structure. This research does not claim that alien signals have been found. It does something more important. It widens the search. It reduces human bias. And it challenges the idea that intelligence must be obvious to be real. Advanced civilizations may not announce themselves. They may conserve energy. They may blend in. Like fireflies in a dark forest, visible only to those who know how to look. If such signals exist, they may already be woven into the cosmic background, waiting. For decades, we asked, why is the universe silent? But maybe that is the wrong question. The better question may be this. Have we been mistaking intelligence for noise, all along?